Hey everybody, and welcome back to Math Pastor in our series called Linear Functions. Last time we talked about what a relation was, what a function was, what domain and range was. But in this second part of this series, we're going to talk about what a linear equation in two variables is. All right, let's break it down. A linear equation in two variables. Well, an equation is just a mathematical sentence that says two things are the same. They're equivalent. Linear means that, and this is the book's definition, or this is most textbooks' definition, any equation whose graph is a line. Now that's useful if you can see what the graph looks like, but if you can't see what the graph looks like, then it's not very useful. So here's another definition. It's any equation where the exponent of the variables is 1. Now check this out. Here's a couple examples. Here's an example of an equation where the exponents are 1. You can see the 1 is written above each exponent. If I erase those exponents, the exponent is still 1. When there's no number written on the upper right of a value, its power is still 1. So this equation, y equals 3x minus 1, because y has no exponent written and x has no exponent written, is still linear. So y equals 3x minus 1 is linear. Now, if I added a little 2 above the x like this function is no longer linear. This equation is no longer linear because the exponent isn't 1 anymore. So any equation that has exponents of the variables, the numbers or whatever, numbers don't matter, the 3 and the 1, they can have any powers they want. But the exponent of the variable, if it's 1, then it's linear. If it's not 1, if it's anything other than 1, then it's not linear. All right, so let's move on. Linear equation in two variables. Well, that's easy. It just means that there's two variables. Most commonly, we'll see x and y as our variables, but they could be any variables. They could be any letters that represent a quantity or a value that changes, right? So remember, variable means able to change or vary. So a variable is any number that you can, any letter that you can plug numbers into. That's what a variable is. So linear equation in two variables is an equation where all the variables have a power of 1 and there are two variables. There we go. There's the title. All right, so that's only the title. Let's move on a little bit though. So when we talk about linear equations, we can do a couple things. We can evaluate linear equations, which means we can plug in numbers and do some math. We can verify if a coordinate, an ordered pair, is a solution to an equation. And we can also use a table to generate points that would lie on the graph of that equation. Those are the three things we're going to do today. All right, now we just looked at the equation y equals 3x minus 1. Now, if we were trying to figure out if a coordinate, if an ordered pair, if an xy coordinate was a solution to this, and solution just means when you plug in the numbers, the statement's still true. That's what a solution is. So if I wanted to figure out if a solution, if a coordinate was a solution, all I have to do is plug in the x and y values and see if my statement is still true. If it is true, then that coordinate is a solution. If it is not true, then that coordinate is not a solution. All right, so check this out. If I had the coordinate 4, 11. Now remember, coordinates are always x, y. So if I have the coordinate 4, 11, then I'm going to plug the 4 into the x position, and I'm going to replace the y with 11 and see if my statement is true. So what I end up with is 11 equals 3 times 4 minus 1. Well, all the math that's being done here is done on the right side. So 3 times 4 is 12, and 12 minus 1 is 11, and it is true that 11 equals 11. So the coordinate 4, 11 is a solution to this equation, which means the point 4, 11 is on the graph of this equation. Now check this out. If I did 2 comma 5, 2 comma 5, if I plug in 2 comma 5, I'm going to see that 5 equals 3 times 2 minus 1. 5 equals 6 minus 1, and 5 equals 5. So 2 comma 5 is also a solution. But does that mean that every number is a solution? Well, let's try 4 comma 1. Now 4 comma 1, if I plug that in, I would end up with 1 equals 3 times 4 minus 1. 1 equals, well, 3 times 4 is 12, so 12 minus 1. And 12 minus 1 is 11, so 1 equals 11. Well, that's absurd. Of course 1 does not equal 11. So that means that this point, this coordinate, is not a solution and does not fall on the graph of this equation. Hey, we can also find solutions to an equation. So we can pick any values for x and figure out what the y is. Now let's go back to that equation we were talking about a moment ago, y equals 3x minus 1. And let's make a table of values. So in this table of values, the left column is going to be my x value. The right column is going to be my y value. Now remember, the first coordinate is always my input, and my second coordinate is always my output. So x is what I'm going to plug in, do some math to, and y is what's going to come out, input and output. All right, so here's what I'm going to do. I'm going to make up a bunch of x values. I'm just going to pick some out of the air. Now, I usually pick 0, 1, 2, 3, and sometimes 4. Those are easy to work with numbers. So when I do that, I'm going to write them down here. 0, 1, 2, 3, and 4. Now I'm going to plug those values into the equation, do some math, and see what y would be equal to. So when I plug 0 in, I end up with y equals 3 times 0 minus 1. Well, 3 times 0 is 0, and 0 minus 1 is negative 1. So when I plug 0 into this equation for x, y has to be negative 1. What's that mean? That means that the coordinate 0, negative 1 is part of this graph. All right, let's move down to 1. When I plug 1 into this equation for x, 3 times 1 is 3, minus 1 is 2, so 1 as my input gives me 2 as my output, so the coordinate 1, 2 is on this line as well. Now if I keep this pattern up and I just plug in the value, so I plug in 2, 3 times 2 is 6, 6 minus 1 is 5, so 2, 5 is on this graph. And then I plug in 3, 3 times 3 is 9, 9 minus 1 is 8, so 3, 8 is on the graph. And finally 4, and we've already done 4. When I plug in 4, 3 times 4 is 12, and 12 minus 1 is 11, so 3, 11 is on this graph. So here are 5 points that are on this graph. Now, the final thing we can do is we've generated some solutions. Now we can use those solutions to graph this equation. Now remember what I said earlier. Some textbooks will define linear equation as an equation whose graph is a line. That's great as long as you can see the graph. If you can't see the graph, that definition is not very helpful. So let's look at these 5 points on a plane, xy plane. So again, xy plane, x is your horizontal axis, y is your vertical axis. Remember, we go left, right first, up, down second. So we have the coordinate 0, 1, negative 1, 0, negative 1. So I move down from the origin 1 unit, make a dot. Then I have 1, 2, so right 1, up 2. Then I have 2, 5, so right 2, up 5. Then I have 3, 8, so right 3, up 8. And finally I have 4, 11, so I move 4 units right from the origin, and then 11 units up and make a dot. Now look at these 5 dots. These 5 dots are all perfectly lined up. In other words, the graph of this equation is a line. If I connect them, they make a line. So we can also graph linear equations by finding a few solutions, connecting them, and drawing the line that is their graph. And remember, lines go on forever, so put arrows on the ends just like this. All right, let's look at a couple more examples just to make sure we understand the kind of homework problems we might see in a section that deals with linear equations in two variables. First, is this a linear equation, or does this equation represent a linear function? Let's look at this one first. We've seen them as y equals. Some books will call that function form. There's other names for it, but whatever it is, it's y equals. So y equals 5x plus 2. Now, if we look at this equation, we can see that the variables don't have exponents written, which means that the exponents by default or are automatically 1. Since the variables have exponents of 1, this is a linear equation. If we had means to graph this, we'd also see that the graph is a line, which makes it a linear equation. Here's another example. Y equals 2x to the third power plus 8. Well, now we look at this and we see that x has an exponent that isn't 1. Now, I don't even care what it is, but it's not 1, which means this is not linear. Here's another one, a third one. 3x plus 2y equals 6. Now, this looks a little bit different, but let's look at the variables and their exponents. Are the variables' exponents equal to 1? Well, there's nothing written there, so they are equal to 1. Therefore, this represents a linear equation. All right, let's look at an example now about checking to see if a coordinate is a solution to an equation. So here is our equation. X minus 3y equals negative 1. This is our equation. And we're going to check 2 points. The first point we're going to check is the point 4, 2. Now, when you plug 4, 2 into this equation, 4 replaces the x and 2 replaces the y, you end up with 4 minus 3 times 2 equals negative 1. Well, 3 times 2 is 6, and 4 minus 6 is negative 2, and negative 2 is not equal to negative 1, so the coordinate 4, 2 is not a solution. The answer is no, it's not a solution. Here's another point. Another coordinate, 2, 1. If we plug 2, 1 into this equation, does it make the equation a true statement? So let's plug the 2 into x, let's plug the 1 into y and see what we get. 2 minus 3 times 1 equals negative 1. Well, 3 times 1 is 3, and 2 minus 3 is negative 1. Negative 1 does equal negative 1, so that means that this coordinate, 2, 1, is a solution to this equation, meaning that it would fall on the graph of this line. All right, here's the final example we're going to do. We're going to graph a linear equation using a table. So the equation we're going to graph is y equals 2x minus 3. So you can see that it's a linear equation because the exponents of the variables aren't there, so that means they're 1. And what we're actually going to see is when we graph this, it also makes a line, which is why it's a linear equation. So y equals 2x minus 3. I'm going to go ahead and create a table. That means I got an x column on the left and a y column on the right. I could make it horizontal. That's okay too. I just like vertical. And then I pick a couple x values. Now you can pick whatever you want. I typically pick a couple negatives, a couple positives, and 0. So I'm going to choose negative 2, negative 1, 0, 1, and 2. These values will work almost all the time. Now, I'm going to use some math to figure out what the y values are that go with each of these x values. So if I take the x and I plug it into where x is in the equation, so instead of 2x minus 3, I have 2 times negative 2 minus 3. I do the math. 2 times negative 2 is negative 4. Negative 4 minus 3 more is negative 7. So that means the coordinate negative 2 goes to negative 7. That's my coordinate. When I plug in negative 1, 2 times negative 1 is negative 2, and negative 2 minus 3 is negative 5. When I plug in 0, 2 times 0 is 0, minus 3 is negative 3. When I plug in 1, 2 times 1 is 2, and 2 minus 3 is negative 1. And finally, when I plug in 2, 2 times 2 is 4, and 4 minus 3 is 1. So then on the right here, I'm going to write down all of my coordinates so they look like coordinates. So when I graph them, it's pretty easy to graph. All right, here are my 5 points. I'm going to go ahead and make an XY plane. So again, the x-axis goes left and right. The y-axis goes up and down. And I'm going to go ahead and plot these 5 points. So -2, -7. So left 2, down 7. Then left 1, down 5. Then I'm not going to move left or right at all for 0, but then I'm going to go down to 3 and make a dot. Then I'm going to move right 1 and down 1 and make a dot. And my final dot, move right 2 and up 1. Here are my 5 dots. They do look like they form a line. I'm going to connect them so they form a line. And then I'm going to put arrows on the end because remember, lines go on forever. All right, so here's how we can use a table to draw the graph of a line. And if I do something wrong, then I would realize that this doesn't make a line, so I must have made a mistake. So here we go. You should be all set now to work on any problems you come up in any homework that deals with linear equations in 2 variables, at least an introduction to it. All right, till next time, guys.